All right. I think we are live. Welcome. Looks like we've got about 20 or so people in here already too, which is great. Hey everyone, I'm Zach Denham. I'm with Bantam Tools, and welcome to the second edition of Engineering from Home. I'm coming to you live from a spare bedroom in my house, like many of you all here. I'm super excited to be on again today with some close friends and really smart people to hopefully share some tips about what's going on in all of our crazy worlds right now. Today we've got Spencer Wright from the Prepared newsletter, among many other cool projects and things. Scott Miller from Dragon Innovation, and Dom Riccobene as well, topographical maps and futurist filmmaker. So today we're going to talk a bit about supply chain and how things have basically been turned upside down amid the COVID-19 crisis. And some housekeeping. We've got a chat going. We'll be keeping an eye on that. And please drop in any questions that you have, and we'll try and touch on those. Towards the end of the stream, we're going to do some very much needed creative distraction, and Dom's going to take over and give us a tour of his lab in New Mexico and share some tips on milling topo maps and a little bit more about his process. So Spencer, Scott, do you guys want to just do a quick intro on who you are and what it is that you do?
Yeah, sure. So my name is Spencer Wright. Zach and I are friends. We also co-own a tiny company making FM radios together. And my normal job these days is I've run the prepared.org, which is primarily an email newsletter that's kind of about manufacturing, logistics, supply chain management, and related distractions, I would say. I live in Brooklyn, New York. The Prepared also has a workshop here in Bed-Stuy, which is effectively closed as of 2 weeks ago. And happy to talk about that more. That's been an interesting saga for me as a landlord and a tenant. Yeah, that's about it.
I'm Scott Miller with Dragon Innovation, and as a background, I'm a mechanical engineer by training. Had the chance to work on some really fun robotic projects, from tuna fish in graduate school to full-size walking dinosaurs for Disney. But I spent the last 20 years of my career really thinking about how to scale from a prototype through high volume. And the first half of that was at iRobot in the early days, when we were trying to figure out how to build the Roomba. I took the prototype, moved to China for 4 years, and had the opportunity to stand up the team there and get to the point where we could build about 40,000 Roombas a week, so roughly 10 containers. And as you can probably imagine, made every mistake in the book, and then got to figure out how to fix it. And then the second half of my career, I've been at Dragon, which I started in 2009, helping other companies hopefully safely navigating that journey of one to many.
Cool. Hey, Dom, just while we're up top too, do you want to give an intro about who you are and what it is that you do as well?
Yeah, sure. I have a degree in film directing from Art Center in Los Angeles. And I'm also kind of in the past, I've been, enter whatever it is, designer, graphic design, web design. But now I'm pretty much exclusively a product designer, as well as a filmmaker, as you'll see on my Instagram. But I design concrete products, landscaping products, and manufacturing methods. And a lot of our products are at big box stores like Lowe's and the garden centers.
Cool. So we'll circle back to you in a little bit, but
Great.
Let's dive in on supply chain stuff. Scott, you maybe to help situate us. So last week I was just mentioning, you did this live stream with Fictive where you were talking about supply chain impacts. Bring us up to speed. Like, what has changed in your world over the last 7 days since you were just discussing supply chain in that conversation?
Yeah, it's crazy how fast things are changing. So what we're seeing now is that, and I should say we build with factories around the world, but a lot of relationships in China. And as we know, over Chinese New Year, they were all shut down, and then that extended quite a bit. We're now seeing about 95% capacity return to China. So the factories are building products. The challenge, of course, is if people are based over here, you can't travel to China. So how do you coordinate that? we've got a team of dragons in China, so it's a little easier for us, just trying to bridge that communication gap. And then on the US side, it seems like manufacturing capacity is reducing. Some is still open and some is not. It also, I think, depends on the size of the factory and the sector that they're in, but it's evolving really quickly.
Yeah, one of the things that's been interesting, at least in the U.S., is some of the stories about, here's a factory that makes circuit boards, or here's a factory like in New York. There was even, I think there was a New York Times, maybe I can't remember where I saw it, but there was a plug about Adafruit spinning up and making, face shields. And so, what is it you've, as someone who spent like a ton of time touring some of the world's largest factories, like what does it take for a manufacturer who produces one product to like wake up on Monday morning and do a 180 and start producing something that is entirely different?
Yeah, so most of the products we build are consumer electronics. So they would have a PCBA or a circuit board, probably some injection molded housings, motors, and maybe gears. And typically, from the manufacturing standpoint, it doesn't really matter if you're building like anything that fits that category, you can basically build. The tricky part is how do you test the thing? And obviously medical products, which are the focus these days, have very different testing requirements in documentation and paper trail than if you're building, a quick consumer electronic product to get out in time for the holidays. So I think the manufacturing side, it is pretty easy to switch gears and, just pick up a different product. But the challenge is, do you have all the facilities and know-how to actually verify and validate that the product's working as it's supposed to? So that would be the bigger challenge.
How are you seeing that play out, at least locally in Boston right now?
Yeah, so Spencer probably has even more up-to-date information on this than I do, but one of our favorite factories is Worthington Assembly out in the middle of Massachusetts. And it sounds like they're still up and operating, and they've got a really big initiative to help with the COVID products, from ventilators to other ways to address that. So I think they, from what it appears, they're able to switch gears pretty quickly. But again, it's their expertise is doing SMT to populate boards and final assembly. We haven't really dug into how we're going to test and validate that those, that we know the product is good after that.
Gotcha.
Yeah, I can say I was actually emailing with Neil from Worthington this morning. And yeah, I know that Chris has been working on a bunch of the ventilator projects. My understanding is that a significant portion of their business is completely on hold. But that the critical things that they do work for some medical device manufacturers. Those are continuing. And then kind of anything related directly to the COVID effort is also continuing as well. So I think it's kind of a mix, right? And I know, not them, but a lot of other companies that I'm in touch with, they're kind of navigating the path of what classifies as essential and what doesn't, trying to figure out if they can, maintain some capacity for things that actually are essential, potentially fill in work, if you're already there on a given day or something like that, finish out the day working on something that's non-essential perhaps, or something like that. Kind of a complicated decision to make for a lot of people, I think.
Yeah, I guess one of the other things, and Spencer, you might have a handle on the conversation around this, I guess Scott as well, everybody. But, one of the things I'm curious about is how did that immediate effect of China shutting down during a crunch time for a lot of companies that were, in the midst of launching a product, create potentially longer term effects for like onshoring some more manufacturing? Like, fast forward 12 months, are we going to see, are people going to be thinking about local production in a different way, do you think, from this?
That's a good question. I would love to think so. And I Scott, maybe you know more about this than I do, but I got an update from Fictiv recently, and my understanding is that, a month ago, they had kind of ramped up production in India because they had lost capacity in China. And then now, of course, as of a couple of days ago, India is completely locked down for, a couple of weeks or so?
Yeah, I think one thing that's happened is that we're um, able to build in so many different countries relatively easily if you have the relationships and know the factories. So if you've got a robust supply chain, you can move the manufacturing to where you need it to be. And maybe partly that's enabled by being able to ship containers, and that's its whole other thing, but to move goods around really quickly. I think for your initial question, Zach, there was, when China shut down, a really big swing to domestic manufacturing, which I love. Like, it's always easier just to build next door. Same language, same culture, drive in, talk to the people, point to what you want to fix. Sometimes as you scale in volume, then that doesn't become as easy to do.
Yep.
But so I think the pendulum swung from China. Well, we've seen it swinging from China to Asia Pacific, not China. And then at a broader term, because of the tariffs and all that good stuff. And then with COVID, it swung to the US when China was shut down. But now that the US is shutting down, I think it's going back to China. And we'll see how that plays out. But it's a really fluid situation. There's also the challenge, if you build it in China, can we still get the goods over here? Are there enough custom agents? And if you're not building a medical device that's a high priority, is that even possible in a timely manner?
Mm-hmm. Spencer, going back to the U.S. side of things, you shared a link about 3M recently, which I thought was interesting. Could you summarize what's going on at 3M right now for people?
Yeah, so I mean, basically, there's been this shortage of the blown-in filter material, right? And I did a bit of reading on this a couple of weeks ago. At the time, it was possible. So N95 masks are made of kind of the mask itself is made of three components. There's an outer cup, an inner lining, and then this blown-in filter material. And that's what's actually the kind of the active component of the mask. Everything is available except for the blown-in filter material, kind of on the open. However, 3M kind of logically, they make their own, right? They are a vertically integrated company within this kind of product line. And this article in Bloomberg, which you just posted, or which Manny just posted in the chat, they talk about how was it SARS or something like that? 2003, I think it was. Mm-hmm. 3M kind of decided, hey, look, like we have to build a bunch of excess capacity that we're never going to use until there's another crisis like this, which to me is, it's an interesting thing. I mean, few companies can operate on the scale that 3M can, and the ability to own that entire vertical supply chain is really special. It makes me wonder whether more companies should be thinking that way, at least on a smaller scale, right? I mean, kind of not sole sourcing, right? Having multiple different supply chains that you can pick from, like Scott was talking about previously, but kind of keeping more of that closer to home as well. And whatever you can develop in-house, it's certainly helpful, because then you have a lot more control of whether you spin it up or not. And so 3M is about to quadruple their production this year or something like that, which is really amazing. And of course it's happening on both sides of the ocean, right? Because the Chinese government a couple of months ago said unilaterally, 3M, you have to make more of these things here in PRC, and at the same time they're thinking, we probably do the same thing in Minnesota as well. Really, really smart move on their part.
Yeah, the machines that make the melt blown fabric are pretty fascinating. I think the filaments are 1/7 the diameter of a human hair, and it takes about 3 months to make the machine, and it's a $4 million machine, at least if I've done my research right. But it's a pretty cool non-woven process.
So basically, like, we're relying on all the machines that exist in the world right now.
That's right. It's going to take a while. It's like a single source, or a finite source. And it's also in some ways good that they're distributed around the globe. Just God forbid there's a natural disaster on top of this. You don't want that sole machine to be taken out.
If you were, Scott, if you had your druthers and this there's more of an enforced policy around. I'm blanking on the term. The sort of wartime policy that the government could instate, where all private factories and businesses are required to actually make goods for this. How would you see that playing out? Like, and maybe how would that best be handled as someone who's been inside these factories, big and small?
Yeah. So there's so many different facets to solving a problem like COVID, and we've been at Dragon trying to learn from this one and then create a Dragon emergency response plan for something we'll hopefully never need. But again, we don't like to make the same mistakes twice. And I think this has been a great learning process. We had, we were no more prepared than anybody else for it. But in many ways, the manufacturing, it isn't the hardest part. I think the trick is figuring out what to build. So there's a lot of things coming out, be it vents, PPE or whatever. But with all of these, there's a chance that you could do more harm than good. And we just don't, at least I just don't know, what's truly the MVP, how do we test for it, and so on. So we could almost think of it like two strands. One is factories or OEMs like 3M and GE and BD that know how to build vents and masks. And how do they scale up? But they should have all the knowledge and facilities and test plans and supply chain set up. So that's how do we get more out of it. And then the other one is more for the makers or companies that want to help solve the problem without access to that. And for them, it's, what is the discovery to figure out what should we actually build? How do we design it to be able to scale? Because these are really high volume problems. How do we select the components so that there is availability, that they're not going to be end of life or a 72-week lead time? How do we source those? How do we finance it? And then how do we deliver it? How do we get it approved? How do we get the hospitals to accept it? And how do we manufacture it? So the manufacturing is just like one, in my mind, like one little part of this really much bigger, more challenging problem.
It's not this thing where the federal government is just like, okay, factories go. There's the logistics side of this that
and this is where I think, like, thank God we haven't been at we've always been at war, but not like a World War II type of thing. But I imagine in a case like that, where you're just mobilizing so many people and the whole nation is doing it, that you've got really good logistics and approvals and the ability to move tremendous amounts of material very quickly. And I don't think we've had to do that, for, 80 years or for quite a while. Mm-hmm. At least at this scale across where everybody's actually on the same team trying to fight this common threat.
So Scott, it sounds like you've been reasonably well integrated into the event and kind of PPE efforts in Boston. I have kind of, I'm in the Helpful Engineering Slack, and I've been kind of like in touch with New York City kind of policymakers here. And I think that I have found it jarring in many ways, kind of considering, like, I imagine that kind of like war powers efforts around World War II were just so incredibly structured, right, top down, and that all this kind of logistics and decision making powers and checks and so on and so forth, those are all imposed in a kind of remarkably strict way for how fast efforts are moving. And I know, at least checking in on the Helpful Engineering Slack, it feels kind of so far to the opposite in many ways. Not to say that it's by the seat of your pants or anything like that. But I wonder, like, what's your impression of kind of that tension there of like wanting to crowdsource this effort on the one hand, and also kind of looking at, from a historical perspective, at these, at least in the 20th century, very top-down operations. How do you see those two things meeting in the middle?
Yeah, so I think you summed up what I'm seeing very well. It's very much a bottoms-up effort. I don't think people have, at least in the circles I work in, we're not receiving a lot of help from top-down. And I think that's spurring a lot of innovation and really, in some ways, bringing everybody together, because we're not looking to be told what to do, but we sort of feel like we got to figure it out on our own. And that's creating all these really strong bonds and getting at least me to pick up the phone and talk to people I haven't for a long time, saying, hey, something about polypropylene that I think could be important. Mm-hmm. So yeah, I think it's a groundswell, and it's a lot of distributed efforts, which inherently has some inefficiency, but also maybe it provides a lot of different designs, and then we can, of those many, pick the ones that make sense going forward with. But I think there's also the risk that you mentioned the term seat of the pants. Like, people truly have the best of intentions, but the event is insanely complex. And the idea that we could design it from scratch in a week and then build the thing is sporty.
That's a good word.
Or potentially.
What I have not seen yet, and what I'd like to, is there's sort of like different circles. So I know the maker circle really well. There's the big circle, like the Tesla circle and that level. And then there's the circle of the companies that build events for a living. I would love to see them open source their test plan. Like, if we knew building an event may or may not be hard, but I think figuring out what to test for is really hard.
Yeah.
And if they would just publish that now, given there's, maybe other issues to consider around IP.
Yeah.
But I'd love to see a little more mixing of the circles.
Yeah.
I think that would help.
I will say the iFixit folks have been publishing repair guides, I think, for commercially available ventilators and other kind of medical equipment. And my understanding is that, it's pushing some legal boundaries maybe. And it seems so obviously a morally good thing to me to be, call it open source, call it whatever you want to, call it piracy. The bottom line is, if people in the field are better able to repair equipment that isn't working and is, in a hospital that is under provision, that seems like a good thing to me.
Yeah, and I think we also, to your comment, Spencer, how does this different from World War II? We have much better tools today than we did, and they're much more distributed. Like, in my basement, I have a carbon fiber 3D printer and a laser cutter. And I know in your shop, you've got all sorts of cool stuff. Like, so we have the ability to build things in a way that didn't exist, 80 years ago.
Mm-hmm.
Yeah, it's been interesting seeing. I was looking at Formlab's site. They had a nice way where they were connecting 3D printer owners with people who were in need. So because I think that a lot of the thing that we're seeing right now is people with some of these tools scratching their heads going, oh, should I make a shield? Should I make this other thing? And how do I get it to the person who actually needs it? And so just finding better ways to network, I think, is,
I have another question for Scott, if I can.
Go for it.
So there was this great article, and I'll find the link, about HEB, which is this grocery chain in Texas. I was not aware of it. My Texan friends say that it's the best. I see that on LinkedIn they have 17,000 employees, which probably means that they have more like 75, right? Because they have a lot of blue collar workers who aren't maybe registering on LinkedIn. And apparently they have a full-time role for emergency and disaster preparedness. And Scott, I guess I'm wondering, like, in the kind of hardware, I mean, that's a really big hardware setup, right? 70,000 employees, or even 17,000 employees is a lot of people. How large do you think that a company should be before they start taking this stuff serious enough to at least devote, a couple days of the year of one person's time, and then kind of ramping that up?
Yeah, so my answer is, if you had asked me a month ago, would be very different than today. But Dragon, we're 25 people, and our plan is not good, but we're starting to have a plan. And I think it, to some degree, depends on what category you're in. So like, food is obviously essential. People need to be fed. If it was building fidget spinners, maybe that IP is less knowledgeable, but the manufacturing could be really important. So it kind of would depend on what you know. And the challenge is that I think now we have a pandemic. In the future, we might have some other problem. You never know what information is going to be critical, but it's nice to know what you know and have other people know that you know that, so that they can reach out to you when it's required. But yeah, I think with us 25 people, we'll definitely have a plan and dedicate some time to it. I think from what I've seen, it took a little while to recognize this was a problem, and then everybody jumped in, and it was almost like a third grade soccer game where everybody's clumping around the ball. And the way it would work, I think best is having small teams. I love the idea of Bezos's like two pizza team, where there's really clear roles and responsibilities, and you just drive it like any other project. But it feels like there's been a lot of confusion around some of the efforts out there, which, like, I'm not saying I would have done it any better. I probably would have screwed it up, but just knowing ahead of time, all right, when this happens, we're going to allocate 3 or 4 days to just understand the architecture of what we're building and the problem. We're not going to like jump in and start building things, and just being very methodical, because we all know the early decisions cast long shadows, and just trying to go through a more measured approach. But again, Dragon wasn't prepared at all, and we're like everybody else trying to figure it out as we go.
Just on a slightly different topic for a minute, Scott, if someone who's listening in is developing a product right now, whether it's like, say, a Kickstarter campaign or something slightly larger, what should people be doing? Sounds like second sourcing, trying to find local suppliers potentially. What is Dragon telling people just in terms of strategy right now?
Yeah, so the supply chain, I think, is going to be the key part to it. And there's it's such an unprecedented time. So we're talking with one group that's working on an event, and they published what sensor they use, just a DigiKey part number. And all of a sudden, everybody bought all that part. So that doesn't exist anymore. And I'd heard, and I haven't verified it, so I don't know if it's right, but Arduinos might be, getting more hard to come by these days. So I think thinking really carefully about what parts you use in your product and making sure ahead of time that they are available. I know outside of this, like multi-layer ceramic capacitors, we're having, going back to a 72-week lead time.
Wow.
So it's sort of like just good practice for BOM health risk assessment would be good. Then the next step is finding a good primary supply chain. So trying to pick vendors and partners in areas that appear to be stable, building the relationship with them, because manufacturing comes down to communication and relationships. And then once that's good, then you can branch out and think about like an approved vendor list, or, trying to make your supply chain more robust. But rather than having maybe 5 relationships for any one part, it's probably better to have a good solid relationship, just so that vendor, if they can, are going to supply you.
All super helpful tips. Spence, anything to report from the New York sort of hardware community? Anything that you're seeing change or come together?
Yeah, I'm guessing that the ventilator efforts are a little bit less well developed. We don't have the same kind of medical research centers that Harvard has, right? The things I'm hearing are mostly like face masks, right? PPE and face masks, which it's kind of amazing following these efforts, and they're talking about shipping 100-unit batch or something like that, which sounds such a tiny number when you think about the scale that hospitals are operating at.
Yep.
And it's kind of frightening, honestly. I think other than that, on a kind of more personal, tangible level, it's weird. It's weird here, right? It's everything kind of hollowed out. Neighborhoods kind of feel the same, right? But So the prepared shop is totally closed down. It's been closed down for the past like 2 weeks, which is odd. And I think that being in a place that has been so kind of energetic over the past 6 months, it's kind of felt so energetic to me. Now everything's kind of closed down, and it's weird for sure.
Yeah. Well, more live streaming is needed then.
Yeah, right. Yeah.
I was just watching Adam Savage's live stream a colleague shared with me, and he's solo in his shop without his typical video crew. And there's something that's actually really comforting in the just brutal honesty and lo-fi production that's happening across the web. So it's at least nice to see people coming together in in like the spirit of collaboration, I think in a genuine way, despite being like everyone being so lonely.
Yeah.
For people who are just joining us, again, we're talking about supply chain stuff. We've got Spencer Wright from theprepared.org, Scott Miller from Dragon Innovation, and Dom Ricobene has been quiet and listening in, but he shortly will be taking on a tour through his shop in New Mexico. Scott, I think we have one other question for you that came in, which is the question is, any tips for vetting suppliers when you can't visit them in person?
Yeah, that's a good question. So we always say the most important thing is to visit the supplier firsthand. So one would be, and again, and this is kind of new territory, one would be a virtual visit, if they're willing to walk around with a cell phone and, give you a tour as if you were there. I think you can still, I've always been a strong fan of asking some detailed question just to see how they answer it. And if you're going on your virtual tour, like my question is always about solder paste. When I'm by the SMT, I'll always be like, hey, just walk me through your process for dealing with solder paste. And I'm a mechanical engineer, so it's a little outside of my realm, but I'm really, rather than the exact answer, I'm more interested in their process for answering it. And if they walk me over to a fridge and saying, okay, this is where we store our solder paste, we have a barcode system where we log it in here, when we want to use it, it comes up to temperature for 4 hours and we put it in the machine. We only run it for 24 hours and we throw it away. Like that's a great answer. If they're like, yeah, I don't know, we get it from somewhere and use it, that's not as good of an answer. So I think if you could still do that while you're virtually visiting a factory, just to see their quality of response, that would be one little trick. The other thing would be if you have somebody you trust that's nearby that can go visit the factory for you if they're operating, that might be helpful.
Cool. Any last must read? Actually, before we pivot to Dom, Spencer, you had this other great link that you had shared about eggs in the UK.
Yeah. It's kind of another like vertical integration thing, except for on a country scale, I guess. And basically, the story is that there are kind of a couple of factors coming together to produce an apparent shortage of eggs in grocery stores in the UK, and the reason isn't a shortage of the actual eggs, because of course chickens keep on laying, right? The reason is that there's a shortage of just boxes, just cartons. And there are, I think, kind of two main factors in this, one of which is that it turns out that most egg carton production is in continental Europe. And of course, the British have kind of taken their own kind of off-kilter approach towards the rest of Europe over the past couple of years. And then the second reason is that, kind of across all food and even toilet paper as well, typically half of consumption is done in the home and half of consumption is done in the workplace or in a restaurant or something like that. And of course, when a restaurant buys eggs, they don't buy a 12-pack, they buy a rack. And so completely different carton, completely different packaging method. And so the result is that there are very few eggs in grocery stores in Great Britain. I mean, anecdotally, I know that our neighborhood grocery store has certainly less eggs than normal. And it's just all about cartons, right? It's such a bizarre thing, and you would never kind of plan a region's supply chain around something like local carton production. That just wouldn't make a whole lot of sense. But
it's so interesting because just in the context of this conversation with Scott, like where you are typically working professionally of helping hardware companies think about what's analogous to the carton of eggs, and now here we are where supply chain this is not just a discussion about supply chain of how to produce a hardware product. This is a supply chain discussion about how to get eggs to your bodega, and it's just interesting that this is just so across the board, and that they're just parallels to how we would think about consuming eggs to consuming SMT components, or the nitty gritty details that happen behind the scene to actually get those pieces to you.
Yep, there's a lot of parallels, and it's one of the principles of a design for assembly is getting it to be as few parts as possible. And the theory is that if you don't have a part, you can't run out of it or forget to order it or not have a vendor. So obviously you can't get rid of the egg carton, but as you do a design, if you can have fewer parts, it's going to simplify the supply chain, which has a almost exponential impact on your success.
Right. The other analogy here, Pete says, as a consumer, might want to consider getting your own chicken, and I think that's I think that's the 3M model, right? Of just thinking ahead and buying these machines in advance.
Yeah.
Well, let's make a pivot for some creative distraction here, and head over to Dom's workshop and lab in New Mexico. Spencer, Scott, thank you so much for sharing some wisdom with all of us. Again, if anyone who's listening should definitely follow along Spencer's newsletter. It's theprepared.org. It's an awesome newsletter covering a lot of the stuff actually that we're talking about today. And Dragon Innovation is where you can learn a lot more about Scott's work and everything that's going on in hardware and supply chain. Anything else that I'm missing that you guys want to touch on before we pivot over to Dom? Okay, cool. Dom, take it away.
Hi there. Thanks for having me today. So to tag on to that supply chain issue, we're having supply chain issues at our company too. We use magnetism in our concrete forming process, and it's a patent pending process, but in those magnets, we order about 500,000 at a time, are from China. And our last order we placed in January, right before the new year. And then we all know what happened after that. So right now they're on a boat, a container ship, all the way over on the Pacific. So it's going to be, another 3 weeks before we get them. But that puts us behind in our mold production, which has a direct effect on our throughput. And just a 4-cent magnet is really causing a bottleneck for us. And we can find suppliers in the United States, but we end up paying 4 times as much for the same magnet. And they actually get their supply from China as well. And so there's still a bottleneck in China with shipments just backed up at the airports because there's so many canceled flights. So we're still feeling the strain from that, but we're going to get past it. But anyways, today I can make this more conversational, or I can just share my screen and go through a bunch of stuff that I'm working on.
Yeah, maybe what would be helpful is can you sort of point people in the right direction of what, if you could pull up a project in front of the camera before we jump into, that would be good.
So first I'll share with you, I get a lot of questions about what I actually do for a living, which I don't really share that much on social media. But I'll share a video about the prototyping process of a product that we've been working on for about 3 years, and we're just now launching it this year. Great timing, but that's what's happening. So here, let me see. Oh, I need to share my screen. Sorry about that. Turn screen share on. There we go. And so what you're seeing me make here, this is what I do at work, is this is a horse and carriage version of a new concrete forming technology we've developed, and specifically to be manufactured with robots and automation. It's a brand new low impact paving system. And if you ever used mosaic tile mats for your kitchen or bathroom, this is the same idea, but for your yard, it's made out of concrete. And this specific design here uses biomimetic geometry to hide the seams, and it's permeable so rainwater can make its way back to the water table. And each mat actually uses half the raw materials per square foot as a traditional paver, so it makes it one of the more sustainable concrete products available. And you'll see here, you can lay it on uneven ground or even a flat slab, and it'll work fine. And you can seed it like I do here, and grow grass or native plants through it, what have you. So that's available at Lowe's right now on the West Coast and in the Southwest, but I'm not going to encourage anybody to go out shopping right now because I don't think that would be the right thing to do. So put it on your list for when the dust settles, whenever that happens. Other questions I get is about my topographic modeling process. I get that question a lot, and I've been putting it off for a while because I wanted to make a clear tutorial, but I'll do a quick primer about how you can easily do it, and also a more complicated way to do it. So the easiest way to do it that I think is with a plugin for Photoshop called 3D Map Generator. You can see the URL up here, and it's a $20 plugin, and it lets you make 3D maps inside of Photoshop. And I don't think you can export an object from that, but what it does is it gives you access to this web interface, and it allows you to select any kind of topography, any location. Let's go to Mount Adams right here. And you can save a PNG height map of that. And that's as simple as that. So now I'll open Aspire, which is one of the pieces of software that I use, CAM software. Sorry about that. So what we'll do is we'll import that bitmap. There's our Mount Adams. Scale it up. And then we'll convert it, create component from that bitmap. And so there it is, but you can see that the elevation of this definitely isn't translating. And you can do things like, change the scale. And, that's around but what it looks like, but you'll see this banding, and that's because PNGs are compressed. And so it's not very high resolution, that image we used, and you can smooth it. And so that's a decent model. And so there you go. In like 2 minutes, I've got a model that I can machine. But for my process, which a lot of people have been wondering about, and finally I'll share it with you today, is I download the data straight from USGS. And this is viewer.nationalmap.gov, and they have a few interfaces for these data sets, but this is my favorite because what you can do is you can show the availability of the different resolutions. So that's 1 arc second. Let's see, 1 meter is pretty spotty, and that's collected by LiDAR, but I always like to use 1 meter when I can. And the US is covered, let me see, 1/3 arc second, the whole place is covered. So if when in doubt, you can go to that, but I like to use 1 meter. And we'll go to Mount Adams here. Let's see. Here's Mount Adams. And then you can draw a square or a box. And then you can go to find products. And it takes a minute to propagate, but here it is. And you can see that it's separated into tiles. And so what I do is I download these tiles, which are raster files, which are image files, really high resolution. And then I open up QGIS, which is a open source GIS software. And I go to raster, miscellaneous, merge. And we merge those tiles together, kind of stitch them together into one. And then what I do is I export that raster conversion translate into a binary ASC file. And I'll show you what that file looks like. And this is the data set, the way it looks in text. And what it does is define the number of columns, the number of rows, cell size. And this is pretty much every point in that model, in that data set, represented as an elevation. Just like in an image, every pixel is represented by a color. In this file, every point is represented by an elevation. And so what I do now is I use Cinema 4D, and I just want to point out that this can be done in Blender using a add-on called Blender GIS, or Blender DIM, I think. And so you can do that identically for free in Blender. So I just wanted to point that out. But I use Cinema 4D because I'm also an animator, and it's easy to integrate into my process. So what I do now is I embed that ASC file that I exported from QGIS, Mount Adams, and it'll take a second to load. This is a 2 GB data set. So it's pretty big, but I've gone up to about 10 gigabytes. And at that point, things start getting a little bit slow and unnecessary for what I'm doing, but it'll load in a moment here. And so here's our data set represented as a 3D model. And it's a little bit low resolution because the subdivisions are down right now. But the next step is to crop it, drag it around. And then once I'm happy with that, I'll up the subdivisions. Let's just take it to the max here. It'll take a second. Now you can see how high resolution these 1 meter data sets are. And I like to use the highest resolution data sets, even though I need to use like a needlepoint to get every detail onto a model. The reason why I use high resolution is because of these sharp peaks here. And when this data is being collected, it's collected by points, and each point is an elevation value. And on the lower resolution data, there might be a point here, a point here, a point here, a point here, and then a point here. And it might miss this sharp peak. So in that model, that sharp peak is going to be rounded, and the whole thing is just going to look a little bit blurry. So I like to go way overboard in the data that I put into the CAM software so I can get those small details. So that's basically the process. I export this and put it into Aspire just like before. But I'll go over a kind of a fun project that I'm working on, and it's a chocolate bar. I'm calling it the Cascadian chocolate bar. And what I did here is I imported 4 different data sets, Mount St. Helens, Mount Rainier, Mount Adams, and Mount Hood. And these are actually all 4 of them at their actual size. So you can see the comparison of the size of those peaks. Then what I did was I combined those up the right dimensions of the chocolate bar that I want to create. And they're still to scale, but proportionally to each other, they're not. So then export that into Aspire that I'll be using for this project. And what I'm doing here is I'm actually modeling the chocolate bar with the tool paths, which is not the way to do it normally. But since I want to work with this high resolution data, Fusion 360 is just going to spit it right back at me. So since I'm kind of aware of my tool geometries and my depths, I think I can pull it off here. So I'll do a preview of how I'm going to go about it on the machine. Rough it out. And this is kind of a new process that I like because of how the time lapse looks, but there's a lot more efficient ways to do this. And then I'm going to use a really fine end mill, like 0.02, to do the detail here, the finishing pass. And this will take probably 3 hours or so. And then I'm going to go in with some V-bits to sculpt the rest of the chocolate bar. So there's the Cascadian chocolate bar. And then the next step is to make a mold for this so I can create the mold. So in Fusion 360, I designed a mold box that's going to be 3D printed. And I'll kind of play the process of that. So kind of build a box around a theoretical model that I made in Aspire. And then what I'm doing here is making a grid. And these have a few different functions, and I'll show you that in a second. And so here's the 3D printed part. And so what we can do is, sure, I'll save it. So drive this into a new file. And we can simulate what this will look like by doing this. We'll make a sketch on that top lip. Project it. And then we'll extrude this down as a new body. So we've effectively filled this mold with silicone. Actually, first, theoretical model there. Project. New body. There we go. And then what we do is we combine, and this is how we design our concrete molds as well. We do the target body as the material we pour into the mold, the tool body is the mold. We cut it, make a new component. And so here's the mold that will produce. And this would be the topography when I actually make it. And so these grids do, this grid does two things. And one is to save material. When we're making our concrete molds, pouring 60 20-pound molds a day, just something as simple as this can save 20% in the rubber use of those molds, and that can add up to thousands of dollars a day. So we like to conserve our material as much as we can. So this is going to reduce the weight by 20%, and also it creates a spillover place where the chocolate that I pour into this mold can spill over and not create a chunk hanging on the side that I'll have to break off. And these pins here for a stamp for the back that I'll definitely machine on the Bantam machine. And this will stamp the names of the mountains on the back so you know which mountain you're eating. So that's my next project coming up. I'm pretty excited about that. And I'm not quite sure when I'll be able to do that because, well, everybody's lives are turned upside down at the moment, but I'll be kind of picking away at it in the next few weeks, definitely.
That's so awesome. Thank you. Someone was dropping in the chat saying this is like an entire college course in ArcGIS. That software is crazy. I remember in the podcast you were describing how it's basically the same software that like FedEx would use to plan shipping routes and avoid climbs. It's wild that you use such big data sets for these. Do you have a small topo that you could put in front of the camera so people can see?
Yeah, I'll grab one real quick.
Okay. For people who are listening in, we had Dom on the Prepared podcast, but the Edge podcast, and he walked us through the whole process of how he uses all of these different pieces of software to create these just really beautiful high resolution maps.
So let's see if my camera wants to autofocus on this. This is, I have to cover my face, I think. My camera's like 4 feet away from me. Okay. I had to use my DSLR. That's not working. There we go. A little bit. So these are the Sandia Mountains here in town. And this was a 1 meter data as well, but I used a 0.02 inch ball-end mill on that one. And so, it's hard to see right here on the stream, but very high resolution. And, you can go to my Instagram, and I use a macro lens to shoot these being made, so you can see, every little detail that way. But yeah.
Awesome. And we dropped a couple links into Dom's Instagram handle. Definitely treat yourself to, spending 20 minutes or so on his Instagram page, because the videos are just amazingly inspiring. So, well, I think we should wrap this up. Thank you again, Spencer, Dom, Scott, for hanging with us today, and hope that everyone stays healthy and stays at home and does your part. We'll be back next week with Nadia Peak from the University of Washington to talk a little bit about what's going on in education right now and how, at least at the college level, people are adapting to trying to teach remotely. And Chris Gamel from the Amp Hour podcast and Analog Life will also be joining us too. So tune back in next Friday at 3, and we'll post links to this probably later today or tomorrow on the Engineering from Home landing page on Bantam's site. Thank you all again so much.
Thank you.
Thank you.
All right. See you guys.